Genetics and computer programs. They're both instruction sets for creating something. We're taking a look at a very simple bit of code here, written in C++, that says, hello world. And if we consider how many characters had to be typed to get this code, ignoring the spaces, it's about 54 characters. Well, what's the possibility of just randomly, typing letters on the keyboard and getting that particular program that says hello world, right? Well, if you look at a keyboard, maybe you could get 70 different symbols out of it through pressing a key on the keyboard, especially if we allow you to sometimes press the shift key along with it. That's, the 26 letters, the symbols above the letters, the numbers, and so on. So about 70 different, possibilities. And maybe you've heard of, people talk about how difficult would it be to have monkeys just randomly pressing keys on a keyboard to get the written work of Shakespeare, right? I mean, if you had enough monkeys and enough keyboards, perhaps at some point, you would, as they were randomly typing on it, they would come up with, Romeo and Juliet, Well, just taking a look at that C++ program for Hello World. To get, to randomly press a letter on the keyboard and just get the very first item correct, that's 1 over 70, right? Because 1 over, 70 different possible symbols. But to get Hello World, it would have to do that not just for the first letter, but for every character after, for all 54 characters. So that's 1 over 70 to the 54th power, which in scientific notation is 4.318 times 10 to the 99, or 1 over this 4318 followed by 99 zeros. Well, just how small of a probability is that, to just randomly press letters on the keyboard and get our hello world in C++? Well, think about the number of stars in the universe. There's 1 septillion. I mean, this is an approximation, and it may even be an underestimate, but 1 septillion, that's 10 to the 24th in terms of the number of stars in the universe. And to get hello world, by randomly pressing some 54 key presses on the keyboard, each one 1/70th of a chance of getting that next character press correct, that's, again, 1 over 4318 followed by 99 zeros. So you have a much better chance of randomly picking, quote, the winning star. If we were playing like a lottery and 1 star of the entire universe was the correct star, you have a better chance of randomly picking that 1 correct star in the entire universe than you would of setting a monkey in front of a laptop and having it press the laptop keyboard, 54 times and getting the working hello world. Well, what about, coding for a very simple organism, right? So I found this in a recent search. It said, hey, a self-replicating bacterium invented by inventor and his team that contains just 437 genes, which is a genome smaller than that of any autonomously replicating cell found in nature, according to the paper, right? So to get this functioning organism was 437 genes. Now, a gene might actually have multiple base pairs, think of this as letters in a word, multiple base pairs to come up with just 1 gene. But I'm going to, for a moment, assume that 1 gene equals 1 base pair. So if you were to have 437 base pairs to code for a very simple bacterium, well, you'd have to get the first base pair right, so that's 1/4, and then you'd have to get the next base pair correct, so that'd be 1/4 times 1/4. You would have to get 1 over 4 to the 437th power. That's the probability. 1 over 4 to the 437th power of just randomly selecting base pairs and getting this organism that functions. So this is what it looks like. Probability of randomly getting organism through random assembly of 437 base pairs. That's 1 over 1, 2, 5, 9, followed by 263 zeros. Now, granted, there could be other simple organisms we could come up with, but this just gives you an idea of just the sheer magnitude involved in randomly assigning base pairs and coming up with something that works. Think about if someone said, "Hey, I have all the parts needed to make an airplane, and here, you put the 747 together." That'd be challenging. But what if they just said, "Oh, we have all the pieces to put together 747 plane. Let's just throw it all together and shake it up and hope it comes out right." Very small. Now this is different than if you have something that works and for it through random mutation to change. So coming back to our hello world, there's 61 characters make up the program. At this point that includes the spaces. So if we wanted this to say, instead of hello world, like jello world, well, there's a 1 in 61 chance that you would randomly select the character where this H is. And then there's a 1 in 70 chance that the H would be replaced instead by a J. So if we were to allow random mutations where one character is selected at random and it's replaced by a random symbol, about 1 out of every 4,270 times you would change its working program from, instead of saying hello world, to saying jello world, right? And let's say that we have the output always checked by a spell checker. So like if it passes spell checker, it's allowed to live. So jello world would be fine. But if it was a mutation, like if it was like lullo world, no such word at this point, then it wouldn't be allowed to continue. Jello world, getting that is so much more likely. Just 1 over 4,270, as opposed to random mutations resulting in a replicating organism, or just getting the program itself, which was 1 over 4318 followed by 99 zeros. So when we look at the natural world, if we have this, for example, a beetle, and let's say this beetle is orange, and it happens to, with a single base pair mutation, now have the ability to be either orange or green, right? So that would be a random mutation. It's not like it could just happen easily, like getting a random mutation to go from hello world to jello world, like that's 1 over 4,270, right? But somehow you hit the lottery, now you can get not only orange but green. And then random selection, let's say there's some crows that like eating, could easily spot, or like eating the green variation of the beetle. Eventually that would get rid of all these green beetles, and what you'd have left would be the orange beetle. Random mutation, natural selection, these things can happen at a much more probable level than getting the working code to begin with. So it is something interesting to think about as we consider random mutations leading to life and leading to evolutionary processes.